material ID is aluminum. For aluminum, the area is given to you as 2400 millimeter square. So I am saying okay. Then I am going to add one more material. So its ID is, let us say, 2. So its cross section area is 600 millimeter square. So now I am going to create the elements over here. So I am going for modeling, create, and say elements. So before creating element, I have to choose the material attributes. So the first part, the material number is consisting of 1 and the section number is 1. So this is the left part. So I am going to the auto number and saying through node. So from here to here, the element is having first material properties and first cross section. Then I am changing this to the second material, and then this section number also I am changing. So section number is 2. I am saying okay. Then I am going for through nodes, and from here to here I have selected this. So if you want to see how this thing is look like, so we can go to the size and shape. We can turn on the shape options, say okay. We can go plot and we can say plot elements. So now we can see this is a thicker element and this is a thinner element. Now this is about the geometry. So now we have to go for the loadings. So for loadings, we are going for define load, say apply structural displacement on the node. So on this node and on this node, the fixed support is there. So I am going for UX and UI. I am putting the value as 0. As mentioned in the problem, that there is a load which is of magnitude 200 into 10 to the power 3 Newton acting at the center. So I am going to apply the load vector by changing this apply structural, say, force on the node. So on this force I am going to apply a horizontal force of 200 into 10 to the power 3 Newton. So the force is now successfully added. Now all we have to do is the solve. So we are going for solution, we are going for solve, and we are solving the current load step. Say okay. So now your problem will be solved and you can say the solution is done. Now we can go to the post processor for